Hi. All right. Here's our second lecture on energy unit. Before we talked about power and work, we're going to talk about kinetic energy and how it relates. So let's get to it. All right. So let's get the PowerPoint up here. And first, we're going to talk what is kinetic energy. And we've kind of talked about kinetics before. Kinetic is movement. Now, we're going to talk about it or abbreviate it as KE. So, number one, it is dependent on both mass and velocity, but not equally. It depends more on velocity than mass. And when we look at the equation, we'll be able to see that. And so the equation here is kinetic energy equals 1/2 mass times velocity squared. And when we do problems here, we have to remember the orders of operations. So in this one, it's really important to know that we have velocity squared, and we have to do that before we do any of our multiplying and dividing in this case. Now, just a quick refresher, M is in mass, and we use that always in kilograms. So we have to double check our units all the time. And velocity is meters per second. And normally, obviously, it has a direction. Our unit for energy, again, we've talked about this, but it is joules. Keep those in mind. And friction opposes this. And we've talked about friction. Now, for us, we're going to disregard friction unless stated. So we're going to pretend that there is no friction. You get further in high school, you can learn more about that in your physics class. So know that it opposes our kinetic energy, but not that we're going to calculate anything with it. All right. Now, we cannot create or destroy energy. That's the law of conservation of energy, or the law of conservation of mass. We just can't do it. We really just change what it is or transform it into a different energy. In our example here on the bottom, notice that the skier on top of this 100-meter hill has a kinetic energy of 0 because they're not moving yet, and is at 0. Potential energy is a lot, 50,000 joules. As they go down, notice the kinetic energy goes up and potential energy goes down, because potential energy, remember, is on height. But a key thing to remember here is 20 plus 30,000 still equals our total of 50. And you can see that at the bottom of the hill, and when they get up, and then finally, when they're at the bottom, there's no height, and they have full speed. So we do not create or destroy, we transfer it. And for us, we're going to talk about transferring from kinetic or moving energy to potential energy, which is height. And here's just another graph to kind of, or picture to look at this. We're changing from potential energy into kinetic energy. Right before we hit the ground, if that diver, it is the maximum amount of kinetic energy, and potential energy would be 0. Halfway, be 50-50. On the top, all potential energy and no kinetic, because we're not moving yet. All right. So we remember from our first lecture that potential energy is mass times gravity, that's G, times height. And because they're conserved, potential energy has to equal kinetic energy. And we just learned that kinetic energy is 1/2 mass times velocity squared. Well, what we can do to simplify this equation is divide out the mass, which makes this equation GH, or gravity times height, equals 1/2 velocity squared. Now, do you have to take out mass? No, you don't. You could still use it. But in a question, if it doesn't give you mass, don't get flustered with it. We can solve it by using this equation. So this bottom equation is pretty important. I would have it written down so I could use it on my assignments. All right, let's hit some questions here. The kinetic energy of an object increases as it's, well, let's go back and think to ourselves, what is kinetic energy? Kinetic energy is 1/2 mass times velocity squared. Well, that would cancel out mechanical energy and potential energy. And we really have never talked about specific heat yet. So our only answer is velocity. And that makes sense because velocity is in the equation. Question 2. According to the law of conservation of energy, the total amount of energy in the universe is, yep, you've got it. It is constant. We cannot create or destroy it, so it remains the same. We just change its form. So the answer to question number 2 here would be A, remaining constant. I should probably go back to this and look at C and D are obviously not a correct answer. Now B is changing constantly. If you talk about that as it's staying the same but changing forms, I like that answer. Also, I don't like the wording of this, but the total amount of energy in the universe is constant. So that's how I would like to use the answer A on that one. So a little clarification there. All right. A rock has fallen 1/4 of its total distance to the ground. What is the relationship between kinetic and potential energy? Here it says all the kinetic energy has been converted to potential energy. Well, that's not it, because remember, still moving, and we're only 1/4 of the way down. 1/4 the potential energy has been converted to kinetic energy. I like that answer because we're only 1/4 of the way down. But let's keep reading. All of the potential energy has been converted to kinetic. No, we're still up there, so we still haven't moved at all. D, 1/4 of the kinetic energy has been converted to potential. Ooh, this one would be a close one, but remember, our potential energy has to do with height. So the best answer on this question number 3 is B. All right, I think this is a tricky one. If you doubled the velocity of an object, you increase its kinetic energy by a factor of, well, let's write our equation down. And remember, here we're talking kinetic energy again. And this equals 1/2 mass times velocity squared. Now, maybe quickly looking at it, we're thinking, oh, we got this 1/2 here, but that really doesn't affect our velocity. So 1/2 we can cross out. And 1/4, maybe we can keep that and look at that just for a second. Now, we can do this mathematically and look at what happens when we double velocity. So all I'm going to do is take velocity down. And remember, velocity in this equation is squared. Everything else remains the same. So let's start with a velocity of 2. 2 squared would be what? And just to make sure I'm doing my math correctly, let me put it in the calculator. 2 squared, of course, is 4. So now let's double that. What's double of 2? Well, double of 2 is 4. What is 4 squared? Well, we can put that in our calculator just to make sure we do our math correctly. And that is 16. So what does it go up? 4 to 16 is a factor of, you've got it, of 4. So kind of a tough question, but that goes back to the question where velocity is more influential on kinetic energy than mass, and that's because it's squared. Question number 5. According to the law of conservation of energy, energy can blank, but it cannot be created or destroyed. I think the answer is D. It can only change on Mondays. No, that's silly. What's the correct answer? Yep, you nailed it. C. All right, let's hit some questions here. We have 2 questions, question 6 and question 7. Question 6 says a 15.0 kilogram bike is carrying a 30.0 kilogram child. What is the kinetic energy of the child and bike if it's moving at 1.5 meters per second? Well, first of all, we want to remind ourselves what is kinetic energy. And this is 1/2 mass times velocity squared. So we're looking for kinetic energy. I'm going to circle that square because that's what I really want to find. And so this question looks a little straightforward. So we're going to find kinetic energy. And we have 1/2. Now a small trick, what's our mass here? Well, we have 2 masses. We have our 15 kilogram bike and our 30 kilogram child. So here we need to add those together. 15 plus 30 will give us a total of 45. And the last question before I type this in or write this in is it in the correct units? Absolutely, we want kilograms. So I'm going to put 45 there. That's our mass. And now, do we have our velocity? Yep, we do. We know that because we remember our units for velocity is meters per second. So I'm going to put that in there. And now we have all our numbers. Now, I think it's really important that we do this part first every time because that's the orders of operations. So I'm going to break it down. If I just did that part first, I would get 2.25. Then I can do the rest of my math. Sorry about the writing. When I do this, I get kinetic energy to be equal to 51, and what's our units for energy? Joules. Now, if you're doing this with your calculator and following along, you may say, hey, Mr. Foss, I didn't get that answer. Maybe in your calculator, you got something like this. Now, what am I doing right here? Sig figs. Remember, this one needs 2 sig figs because the 1.5 only has 2. So there's a question that uses kinetic energy and we solve for. Let's do one more. Question number 7. What is the mass? Ooh, I'm going to stop right there because it tells me what I want to find. We want to find the mass of an object that is moving with a speed of 33.2 meters per second and has a kinetic energy of 1.3 times 10 to the 5th joules. Okay, so we got to know what equation to use. Our key here is, again, we're talking kinetic energy. So we can go back to kinetic energy equals 1/2 mass times velocity squared. Now we could rearrange the equation right away, but what I'm going to do in this case is I'm going to plug in all our numbers. In this equation or this question, it gives me kinetic energy. So 1.30 times 10 to the 5th. And I know that's kinetic energy for two reasons. Number one, the word in front of it, and then number two, because of our units. That's going to equal 1/2. That's not going to change. Mass is what we're looking for. And our velocity is given, and it says speed. And remember, speed and velocity are very similar to each other, and squared. Now, I really think the math of this gets a little crazy. And what do we have to do first? We've got to get that square to the velocity taken care of. So if you put in your calculator 33.2 and square it, you should come up with 1,102.24. I'm going to double check that just to make sure on my calculator I did it right the first time. And that's what I get. That will equal our mass, and we still have 1/2. So we really didn't do a whole lot, just setting ourselves up for success. Now we can divide them. Now I don't care this part, because you can divide by 1/2 or divide by that 1,000 first. But the real key is this, making sure we put this into our calculator correctly. So if I'm entering that, I'm typing in 1.30. And in my calculator, remember, I have to hit the second and the EE button to the 5th. Now I like to hit enter after that. And now I'm going to divide by 1/2, which is 0.5. Hit enter, and then divide by 1,102.24. That takes all of this stuff over here to the other side. When I'm done with that, I get mass being 235.88 in my calculator. Now, we know we can't have that. What's our number of sig figs we should have? Looking in the question, both of those have 3. So let's change this to 3. And we'd use the 2, we'd use the 3, and the 5 we need to round. And let's put our units on there. What's our units for mass? Yep, nice job. Kilograms. So there's a question where we use the kinetic energy to actually find the mass of an object. All right, we'll see you in class. We'll be able to do some questions on your worksheet and keep going. So we'll see you then.